Welcome Chemistry 19.2. So here's some answers to the top part of this. One is transmutation. Transmutation is just one radioactive element turning into another. 2 is radioactive decay. 3 is alpha, again, from the other day. The paper could stop it kind of stuff. 4 is beta from the other day. The foil stops it, kind of stuff. 5 is a decay series, which I'll look at page 568 for a minute at a decay series with you. 6 is gamma, Bruce Banner and the Hulk, that kind of thing, back in action again. So that's the top 6. From 7 down is just a repeat from the other notes, other videos, so you probably have those already. In terms of what's going on for next time with those words, 19.3 is the read, and there will be 7 points, 1 scientist name, and 6 fill-ins from reading 19.3. And then the rest of this changes some, let's see. Number 7 gets abandoned. So does 8 to 15. All the scientists that were on today, they go away. They'll be back on the test. But as I said last time, this chapter is very heavy on vocabulary, and so the words don't necessarily stay for a long time. 16 today stays, so does 17, 18 stays, 19 to 34 stays, and we'll ask you for 2 new items. It'll ask you for a shorthand way to write them in equation. So in the alpha club, alpha was the fishy. Anything that you're asked to write an equation, and I'll do a couple equations in a minute, this is the symbol for an alpha particle. Also in the alpha particle there, just by way of review, it was a positive charge, low penetrating power that paper could stop it, a high danger level, and a bonus fact, not extra credit, but an additional fact that it can ionize gases. We talked about smoke detectors. Beta, this is the shorthand scheme for beta, but the group there in 19 to 34 should have read beta, had the symbol, it was negative, medium penetrating power, the foil could stop it, medium danger level. Gamma was this symbol, it's neutral, high penetrating power, lead concrete could stop it, and it was a low danger level on gamma. But next time you do that big list, these 2 things add in to make the cut in addition to what you had before. 35 stays the same, 36 stays the same from today's. Today's number 1 goes backward. What is a transmutation? It's just a change of a radioactive element into another element, which might be radioactive or might not, depends. 2 stays the same. 5 goes backward. What is a decay series? A decay series is a series of changes undergone by radioactive substances until they become stable. So transmutation is one change, and maybe it'll change again. A decay series is a bunch of changes that it won't stop until you don't have anything radioactive anymore and you have what's called a stable substance. Which lends itself to a next question, what is a stable substance? And that's a question next time that finishes the tomorrow quiz. What a stable substance is, 2 facts, 2 half of an answer. It's not radioactive, or meaning it does not emit radiation. So I told you I'd look at page 568, so let's do this here. I think in the homework they'll ask you to talk about a decay series. And this is the only decay series you really have access to at your fingertips, is on page 568, the U stands for uranium. If you follow the arrows, the U for uranium undergoes a whole lot of changes before it ends up being at the bottom of this thing, Pb, which is lead. Lead is, some types of lead are radioactive, but some types of lead are not. So this decay series has uranium giving off an alpha particle to become thallium. Thallium is what killed Mr. White in the James Bond movie Spectre, I think. Thallium gives off a beta particle to become palladium. Palladium is radioactive. That's also in movies. That's Iron Man 2, I think, is what his generator was running on there in his chest to keep him alive. I think it was palladium that was poisoning him. Uranium is the next thing, then a different thallium, then a radium, then a radon, which is noteworthy because that can give you lung cancer if it's in your home, to polonium, to lead, to bismuth, to more polonium, to a different kind of lead, to a different kind of bismuth, to a different kind of polonium, finally to lead, and it stops because that last kind of lead is not radioactive, it's a stable substance. So all of these beginning substances are radioactive. They can change into other things by kicking off these alpha and beta particles, but this last lead is stable. This whole big thing is a decay series. Any one of those moves is called a transmutation. One thing turns to another down the line. Homework type things, if you can add or subtract, you can do the homework. So the math in this chapter is not heavy. Adding and subtracting is about as far as this goes. You just need to know a little bit of information about these kind of things to get going. So before I get going, quick reminder, whenever you see these things written, there's always an element name or some kind of a name that goes where X marks the spot. This is helium, this is E for an electron. The top number is always called the mass number. That's the protons plus the neutrons. This has none. This has 4 proton-neutron total combos. The bottom number is always called the atomic number. That's just counting the protons. So this has 2 protons. This would also have 2 more neutrons to bring the total mass up to 4. This has -1 protons if you want to look at it that way because it's an electron, but it doesn't have any total of protons and neutrons. It has no mass. Electrons have no mass is another way you could say that. But we need to know these symbols to do our adding and subtracting. So I'm looking now 569. 569 says radium-226 decays by alpha emission. So what you'll have to do to start your equation is to write an Ra for radium. The 226 goes up top, and then you'll have to use your periodic table to figure out radium's atomic number. Radium's atomic number on the table is 88. It's down there in the 7th row, or 7th period. So radium has an 88. So radium's what it starts with. It says it's going to decay by alpha emission. Emission means it's coming out, so that means it's after an arrow. We've done these chemical formulas with arrows before. An alpha, one of these is the name we're going to use for alpha, goes after the arrow. And then we just have to do math to make this add up right. 4 is going to add something new to make a total of 226. To have a total of 226, 4 would have to add 222. Likewise, the 88 is the total of 2 and a mystery number, which has to be 86. 2 plus 86 is the only way you can make 88. And then to decide which element is number 86, you'd use your periodic table again. Element number 86 is Rn, which is radon. So that is, again, an example of a transmutation. We start with radium, which is radioactive. It kicks off an alpha particle, then you have radon instead. You just wrote your first ever nuclear equation. You want to feel smart, tell your friends you're writing nuclear equations in your homeschool world on your own, just don't say nuclear. 19.2 problem says bromine 82. So we start with bromine, and 82 is the top number. To do the bottom number, you need your periodic table. Bromine's number on the periodic table is 35. We're again doing emission. So after the arrow, we're going to put something over here. Emission means it's coming out. Beta emission, though, this time. So for beta, we grab this. And And then we just need to have it make a friend to make the math be able to be consistent. 0 plus something has to make 82. The top numbers have to make an adding problem that works. For 82 to be equal to 0 plus a mystery number, that mystery number has to be another 82. -1 has to add this to become a 35. So the -1 is going to take 1 away from 36. 36 adding -1 is the only way to get 35. And to figure out what element this is, we need to look to our periodic table for number 36. The bottom number is the key to the periodic table. 36 is Kr, which is not kryptonite, but it is krypton. Kryptonite is only in science fiction, Superman kind of stuff. But that's what you're going to try to do tonight with homework problems that go 3, 4, there's some scraps and pieces. 1 goes through the letters A to I, 2A is in there, 3 and 4 are in there. 3, you're going to just be, let's see if that's the one I'm writing. 3 is just using the symbols. 4, they want you to describe a decay series, so you would have like a 15-sentence fragment plan like I did when I looked at page 568 and I took you all the way from uranium to lead. You're going to have to like describe that in your own words there. That's number 4. But the main part of the homework's 9 and 10. 9 and 10, you're writing some of these kind of equations. So, see you later.